yesterday we started section 4.1, angles and their measurement, and we learned two different ways to measure the size of an angle. The idea with degrees is that we have an initial side to our angle, and the idea behind degrees is one full revolution is equal to 360 degrees, right? We assign 360 degrees to one full revolution. The idea behind radians is that we have a circle we have an initial side right in the terminal side of the angle, and the radius, right? The radius of the circle is r units, and the length of the arc between the initial side and the terminal side here is also r units. And so the angle, call it theta here, between the initial side and the terminal side is one radian. Right, and that's where we ended it at top page 2 yesterday. Okay. So radians as a measure of angles, right, is based on arc length. Okay. All right. And when we were talking about angles in degrees, right, we said that an angle drawn in a counterclockwise direction is positive, and an angle drawn in a clockwise direction is negative. And we have that same convention for angles and radians, right? If they're drawn in a counterclockwise direction, they're positive, and if they're drawn in a clockwise direction, they're negative, right? They have a negative sign. So let's look at these 4 examples. The angle pi over 2, that's 1/4 of a revolution drawn there. And remember, there are 2 pi radians equals 1 revolution, right? That's 1 trip around the unit circle, right? Circle of radius 1. So there are 2 pi radians in 1 revolution. And so you can see from the graph, right, the angle drawn is 1/4 of a revolution. And so 1/4 of 2 pi radians is equal to pi over 2 radians. In the second graph, okay, we have the angle minus pi over 2. And so that's drawn in a clockwise direction. You can see that's a 1/4 revolution in a clockwise direction. So since it's clockwise, we say it's minus 1/4 of a revolution. And minus 1/4 times 2 pi radians is equal to minus pi over 2 radians. In the third graph, right, we have the angle pi. You can see that is a 1/2 revolution, right, from the initial side to the terminal side, and 1/2 revolution times 2 pi radians equals pi radians. And then in the fourth graph, right, we're going more than 1 revolution. Following the spiral, right, the initial side's along the positive x-axis. This is the terminal side of the angle along the negative x-axis. And following the spiral, we go 1 full revolution plus a 1/2 revolution. Okay. And so 1 full revolution plus a half a revolution is 3/2 revolutions. Multiply that by 2 pi, and we get the angle 3 pi radians. Now, they're not drawn on the same graph, okay? But you can see that pi and 3 pi are coterminal angles because they have the same terminal side. Right? We could have drawn them on the same graph, but it would look kind of messy. So we draw them separate graphs. But the terminal side for both those angles is along the negative x-axis. And so pi and 3 pi are coterminal angles. Okay? And the exercise is find 2 angles that are coterminal with 2 pi over 3 radians. Sketch the angle. Okay? Well, in the first graph, right, we had the angle pi over 2 radians. Pi over 2 is the same as 1/2 times pi. And then we're going to graph, we're going to draw the angle 2 pi over 3 radians, which is the same as 2/3 pi. So if we think of, instead of using the word, the number pi, we think of PIE, 1/2 of a pi, which is bigger, 1/2 of a pi or 2/3 of a pi? 2/3 of a pi, right? So the angle 2 pi over 3 is going to be greater than pi over 2. But 2/3 of a pi is less than a whole pi. So the graph, so the angle 2 pi over 3 is going to be greater than pi over 2, but less than pi. Okay. So the terminal side of the angle is going to be somewhere in the second quadrant. Right? It's going to be greater, the angle is going to be greater than pi over 2, but less than pi. So here's the initial side. And then the terminal side is going to be somewhere in the second quadrant. So this is the graph of the angle 2 pi over 3. Okay? It's bigger than pi over 2, but less than pi. Okay? Find 2 angles that are coterminal with it. Well, yesterday in talking about angles and degrees, right? Angles that are coterminal in degrees are differ by an integer multiple of 360 degrees. So with radians, any 2 coterminal angles measured in radians would differ by an integer multiple of 2 pi. So one way of getting a coterminal angle with 2 pi over 3 is to add 2 pi to it. That's one full trip around, that's a 2 pi is one trip around a circle. So 2 pi over 3 plus 2 pi Three is the common denominator. So 2 pi is equal to 6 pi over 3. And then now I gotta come to the denominator, I add the numerators, and I get 8 pi over 3. So 8 pi over 3, that angle is coterminal with 2 pi over 3. Okay. If I were to draw that angle, which I'm about to do, here's the initial side. Here's the angle, right, from here to here is the angle 2 pi over 3. And then when we add 2 pi, we're adding 1 full revolution to 2 pi over 3. And when you add 1 full revolution, it brings you right back to the terminal side. So this is what the angle 8 pi over 3 looks like. You gotta add 1 full revolution. Does anybody know what another coterminal angle would be?
Negative 4/3 pi.
Yeah, negative 4/3 pi or negative 4 pi over 3. So we can subtract 2 pi from 2 pi over 3. And when we do that, remember, so instead of adding 6 pi over 3, we subtract 6 pi over 3. And we get minus 4 pi over 3. Okay. So going back to our original graph over here, if the rotation from the initial side to the terminal side is in a clockwise direction, that creates the angle minus 4 pi over 3. And minus 4 pi over 3 and 2 pi over 3 share the same terminal side. So they're coterminal angles. Okay. So 8 pi over 3 minus 4 pi over 3 and 2 pi over 3 are all coterminal angles. Any questions on that? Coterminal angles are going to be very important in the next section when we learn about cosine function and sine function. Okay. And so that's why we're talking about them now. All right, at the bottom of the page gives you a formula for converting from degrees to radians and radians to degrees. If you flip over your page to top of page 3, we're going to talk about that in a little more detail. So 360 degrees, we know, is equal to 1 revolution. And we know that 2 pi radians is also equal to 1 revolution. So it immediately follows, since 360 degrees is equal to 1 revolution and 2 pi radians is equal to 1 revolution, it immediately follows that 360 degrees is equal to 2 pi radians. Those are the same angles, okay? Just different measurements, okay? If I divide both sides of that equation by 2, we have 180 degrees on the left is equal to pi radians on the right. Okay. And it's standard convention to, instead of writing out radians, just to write rad, R-A-D. If we take our original equation, 360 degrees is equal to 2 pi radians, and divide both sides by 360. 360 divided by 360 is 1, so we get 1 degree on the left, and then the numerator and denominator right are both, we divide both the numerator and denominator by 2, and you get pi over 180 on the right. So 1 degree is the same angle as pi over 180 rad. Okay. I see. Are you not believing me?
I'm just confused.
What are you confused about?
Like, so what was the other side for?
Where?
On the other side of it, when I did 180.
Over here?
Mhm.
So 360 degrees and 2 pi radians are the same angle. So if we divide both sides of the equation, it's also true that 180 degrees and pi radians are the same angle.
Okay.
Okay? That's all we're saying. Okay. All right. So we divide both sides by 360, right? We get 1 degree and pi over 180 radians, right, are the same angle. And then, taking our original equation, 2 pi radian, or switching the two sides of the equal sign, we have 2 pi radians equal to 360 degrees. And if we divide both sides by 2 pi, we have 2 pi over 2 pi is just equal to 1. And so we end up with 1 radian is equal to, 2 goes into 180 times, so we end up with 180 over pi degrees. Now, that's how it's written in your notes, okay? I prefer just to write out the word degrees. One radian, right, is 180 degrees over pi, or 180 over pi degrees. Okay. So those are the two conversions factors for converting angles from degrees to radians and radians to degrees. So in example 4, right, you got to convert 135 degrees to radian measure. Well, 1 degree is equal to pi over 180 radians. So I can multiply both sides of this equation by 135, and I have 135 times 1 degree. Well, let me rewrite this. 135 degrees. I can multiply both sides by 135. 135 degrees is the same as 135 times 1 degree, which is right. So I'm multiplying left hand side by 135. Now I gotta multiply right hand side by 135. So then I have 135 times pi over 180 degrees. 135 times pi over 180 radians. Well, that is equivalent to 135 pi over 180 radians. And I gotta simplify the fraction, right? And the numerator and the denominator, right, are both divisible by 45. So when I divide the numerator and denominator by 45, I get 3 pi over 4 radians. So 135 degrees and 3 pi over 4 radians are the same angle. Okay? Just different measurements, just measured differently. Now, students are going to ask, what you actually have to do maybe on exam, you're asked to convert 135 degrees to radians, right? You just got to go from here to here to here. You can skip the middle 2 steps. Okay. I just put it up there to show you how we got there. Okay. Alright, in example 5, we gotta convert 2 radians to degree measure. So, we're gonna use this formula right here. Okay. Multiply both sides by 2. And we'll get 2 radians is equal to this times 2. So 2 radians is equal to 2 times 1 radian, right? I'm multiplying both sides by 2, which is equal to 2 times 180 degrees over pi. 2 times 180 is 360. And so 2 radians is equal to 360 degrees divided by pi. But I would be so inclined to write 360 over pi degrees. All right. Any questions? I'm going from radians to degrees, degrees to radians. Length of a circular arc. So that's what radian measure is based on, right? Arc length. So let me draw a picture. Here we have a circle. And then we have the central angle theta. The central angles where you put the vertex of the angle at the center of the circle. Okay. The radius of the circle is r units. So the distance from the center to where each ray crosses the circle is r units. And then the length of the arc between the 2 rays is s units, right? That's not a phi, that's an s. Okay. And theta is measured in radians. Then the relationship between the length of the arc s, the radius of the circle r, and the angle theta is given by the formula arc length is equal to the radius times the angle theta. Okay, it's a very simple formula. So in example 6, you're given the radius of the circle is 5 centimeters, and the length of the arc is 3 centimeters. Find the measure of the central angle theta in degrees and radians. So first we're going to find the value of theta in radians and then convert that answer to degrees. Okay. So S is equal to R times theta. So if I divide both sides by R and switch the 2 sides, we get the central angle theta is equal to the length of the arc divided by the radius r. Okay. Well, the length of the arc is 3 centimeters, and the radius of the circle is 5 centimeters. And so this angle theta in radians is equal to 0.6. So theta is equal to 0.6 radians in this problem. Okay. Now, to convert this angle to degrees, you got to multiply 0.6 by the appropriate conversion factor, right? Theta is equal to 0.6 radians, which is equal to 0.6 times 180 over pi, 180 degrees over pi. So you gotta multiply 0.6 times 180 degrees. Over pi. And when you carry out that calculation in the numerator, you get 108 degrees over pi. So the angle theta is equal in radians, the size is 0.6 radians. In degrees, its size is 108 over pi degrees. Any questions on that? All right, we have a little definition here. Two acute angles are said to be complementary if their sum is 90 degrees. Two positive angles are supplementary if their sum is 180 degrees. So remember 90 degrees or you can verify this. 90 degrees is equal to pi over 2 radians, and 180 degrees is equal to pi radians. This is at the top of the page, right? So in example 7, part A, you're asked, find the angle that is complementary to pi over 6. So to find the angle that's complementary to pi over 6, we subtract pi over 6 from pi over 2. Because pi over 2 radians is the same as 90 degrees. So pi over 2 minus pi over 6 is equal to 3 pi over 6 minus pi over 6, right? 6 is the common denominator, which is equal to 2 pi over 6, which is equal to pi over 3. So pi over 3 radians is the angle that is complementary to the angle pi over 6. All I did was subtract pi over 6 radians from pi over 2 radians. Pi over 2 radians, same as 90 degrees. Find the angle that is supplementary to 83.5 degrees. So to find that angle, I subtract 83.5 degrees from 180 degrees, and I get 96.5 degrees. So the angle 96.5 degrees, okay, is supplementary to the angle 83.5. Okay. The sum of 83.5 and 96.5 is 180 degrees. Any questions on that? Area of a circular sector with radius r and central angle theta is given by that formula. So let's get a visual of what's happening here. So here's a circle, again with radius r. Here's my central angle. All right, the vertex at the center. And so, again, the distance from the vertex or the center of the circle to where each ray crosses the circle, right, is our units. And the angle between the two rays, right, is theta. And theta, again, is in radians. All right, these formulas only work if theta is in radians. So the sector, okay, is this shaded area. So if you think of this circle as a pie, P-I-E, right, the sector is a slice of the pie. And so the area of this of that sector, right, is given by the formula 1/2 r squared theta, where theta again is in radians. Okay. So we're given r is equal to 3 millimeters, and theta is equal to 3 pi over 4 radians. So we plug in for r and theta, and we have 1/2 times 3 squared times 3 pi over 4. And when you carry out that arithmetic, 3 squared is 9. 9 times 3 is 27. So we have 27 pi in the numerator. And then 2 times 4 is 8. So the area of the sector is 27 pi over 8. Area has what for units? Well, let me rephrase this. Okay. So we're given that the radius is millimeters, right? 3 millimeters. So what's that? What for the units going to be for the area?
Millimeter squared.
Yeah, millimeters squared, right? Any questions on that? All right, if you flip over to page 4, at the very top there, right, since we're talking about converting from degrees to radians and radians to degrees, you can verify these numbers, right? But this, for some popular angles, 0, 30, 0 degrees, 30, 45, 60, 90, 180 degrees, right? Also gives the corresponding radian measure, and you can verify those, right? Those are important angles that you should become familiar with. And then we have some terminology, and you can read through the terminology on your own at your leisure. Okay? So any questions on 4.1? Introduction to angles and their measurement. Okay. All right, so we'll move on to 4.2, where we'll learn about the cosine and the sine function. All right. So in this section, we learned about the cosine function and the sine function. And maybe like many of you who had trigonometry in high school, how I learned trigonometry, I recall, is from what's called right triangle trigonometry. Based on here's the right triangle, right? Right triangles have a 90-degree angle. And this is like the angle theta. And this is called the opposite side. And it has a length of B, and this is the adjacent side, has a length of A. And then that's the hypotenuse. And you learned about the cosine of theta and the sine of theta, right? Using the three sides of a right triangle. Well, for calculus purposes, we're going to learn about the trigonometric functions a little differently. And the way we're going to introduce them does not contradict what you learned from right triangle trigonometry, right? It does not contradict that. All right. So in the graphic, top of page 1, we have a circle. And the center of the circle is at the origin in the coordinate plane. And the radius of this circle is 1 unit. So the equation for this circle is x squared plus y squared equals 1 squared, which is 1. And that's why it's called a unit circle, because the radius is 1 unit, whatever your units are. Okay? And you know that every point on the circle, right, the x and y coordinates for that point have to satisfy this equation up here. And so it crosses, you know, the x-intercepts in the graph of the circle are at 1, 0, minus 1, 0, and the y-intercepts are at 0, 1, and 0, minus 1. Okay? Now, for any real number t, so from a set of all real numbers, you pick a real number, right? We call it t. I can draw an angle in radians for that value of t. Right? So you know the initial side goes along the positive x-axis, and then the terminal side, right, somewhere in the coordinate plane. So we'll draw it like this. And so there's an angle of t radians between the initial side and the terminal side. And so when I'm drawing, I'm assuming t is positive in my example. T can be negative, and we draw the angle in a clockwise direction. Okay. Well, where the terminal side crosses the circle, I'm going to label that point P. Okay. And that point has an x coordinate and it has a y coordinate. And that x coordinate, y coordinate have to satisfy the equation of the circle. Okay? Because that point is on the circle. Okay? Well, by definition, that's an important phrase, by definition, okay? What we call the cosine of the angle t, which we denote with COS, short for cosine. The cosine of the angle t is equal to the value of this x coordinate, where the terminal side crosses the circle. And the sine of the angle t, which we denote with SIN, is equal to the y coordinate. Okay. And so that's really our basic definition of the sine function and the cosine function. Okay. The cosine of this angle t in radians is equal to the value of this x coordinate, where the terminal side crosses the circle. And the sine of the angle t in radians, okay, is equal to the y coordinate where the terminal site crosses the circle. Okay. Now, cosine and sine, they are functions just like f of x. Okay? So if I have f of t, you know that f is the name of the function and t is the input variable, right? I'm using t instead of x as my input variable because t is our input variable, right? The angle in radians. And so cosine t could be written as the cosine of t, right? Cosine is the special name of a function, and t is the input to that special function, right? The input is the angle t in radians. Well, remember with the natural log function, sometimes we enclose the argument with parentheses, and then sometimes a lot of times we just drop the parentheses. Well, because this is a special function, we often just drop the parentheses. So when we write this, cosine of the angle t, right, we're really thinking in terms of function notation. Okay? And the same is true for the sine function. The sine of t, right? Sine is the special name of a function. T is the input variable. And often because this is a special name, we just drop the parentheses a lot of times. And so when you see this, we're talking about sine of t, just like in algebra, right? When we're doing algebra, we talk about f of t, okay? And g of t, and so forth. Okay? All right. Any questions on that thus far? So this is by definition what sine and cosine are. Okay? All right. So the equation of the unit circle, as I've already written up here, is x squared plus y squared equals 1. And all the values of x and y on the circle are between, right, the values of x are between minus 1 and 1, and the values of y are between minus 1 and 1. And so since cosine of t is equal to x, when I replace x with cosine of t, I get the cosine of t is also between minus 1 and 1. And similarly for the sine of t. Since sine of t is equal to y, sine of t is between minus 1 and 1, right? So that is the minimum and maximum values of the sine function and the cosine function. Okay? The sine function and cosine function will never take on a value below minus 1 or above plus 1. It will always be between minus 1 and plus 1. Okay? Remember the Pythagorean theorem? So here we have a right triangle, right? That forms that vertical line forms a right angle with the x-axis. The width of that right triangle is x, which is equal to cosine t, and the height of that right triangle is y, which is equal to sine t. And you know the Pythagorean theorem, right? X squared plus y squared equals 1. So here's the equation of the unit circle, x squared plus y squared equals 1. Well, x is equal to cosine t, right? Or cosine t is equal to x. So I can replace x with cosine t, and I can replace y with sine t, and I get this equation down here. Cosine t squared plus sine t squared is equal to 1. That's not normally with the trig functions, how we write a trig function squared. We actually move the 2, instead of instead of writing cosine t in parentheses and then squaring it, we put the 2 as a superscript on cosine. And the 2 is a superscript on the sine. So when you see this is cosine squared of t, it means cosine of t quantity squared. Okay? So these two mean the same thing, but this is the notation that you will often see. Okay? And so this is the type of Pythagorean identity. Okay? This is actually an identity. And this is true for any angle t in radians. Okay? All right. So if you flip over your page, we're going to use the unit circle to find the following trigonometric values. The first one is sine pi over 2, okay? And so I provided you, right, for each of these cases, a unit circle, right? And you can see the x and y intercepts are labeled, like we did already over here, okay? In the first case, we got to find the sine of pi over 2. Well, just to remind you, that angle, pi over 2 radians, is the same as 90 degrees, okay? So here's, I'm redrawing the unit circle. Here's the initial side. So now I'm drawing the angle. Pi over 2 radians are 90 degrees. Here's the initial side. Here's the terminal side. And the terminal side crosses the circle at the point 0, 1, right? 0 is the x coordinate, 1 is the y coordinate. So the sine of pi over 2 is equal to the y coordinate, which is equal to 1. Okay. What's the cosine of pi over 2 equal to then? It's equal to x. What's x equal to? Yeah, so you can also add cosine of pi over 2 is equal to the x coordinate, which is 0. And then any questions on that? In the next case, we got to find the cosine of pi. So here again, the unit circle. And pi is the same as 180 degrees. So here's the initial side, and here's the terminal side. Right, that's a graph of pi radians, right? Same as 180 degrees. And so the terminal side crosses the circle at the point -1, 0, right? At that point right here. So -1 is the x coordinate, 0 is the y coordinate. And so the cosine of pi is equal to the x coordinate, which is -1 in this case. The sine of pi is equal to the y coordinate, which is equal to 0 in this case. Are you with me? Does that make sense? Good. And it's all based upon our definition, right? By definition. Okay. Then lastly, we got to find the sine of minus pi over 2. So I've already provided you with the unit circle. And so the angle minus pi over 2 is the same as minus 90 degrees. So here's the initial side. Here's the terminal side for minus pi over 2 radians, right? Minus 90 degrees. And so it crosses the terminal side, crosses the circle at the point 0, minus 1. So the sign of minus pi over 2, you notice how we put minus pi over 2 in parentheses, right? Just to clarify things, right? Sometimes we use them, sometimes we don't. Okay. The sign of minus pi over 2 is equal to the y coordinate, which is equal to negative 1 in this case, right? The x coordinate is 0, the y coordinate is minus 1. And then cosine of minus pi over 2 is equal to the x coordinate, which is 0. Okay. Any questions on that? Okay. All right, the signs of the function values sine t and cosine t are determined by the quadrant in which the point P lies. Okay. Remember, the point P is determined by the terminal side of the angle. So I'm going to draw the unit circle again. So if the terminal side of the angle crosses the circle in the first quadrant, right? Broken up into quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay. So if the point P, right, the terminal side crosses at this point, right, the terminal side of our angle. That point has an x coordinate and a y coordinate, right? In the first quadrant, all x coordinates are positive and all y coordinates are positive. Okay? And since cosine t is equal to x, it's positive, and since sine t equals y, it's positive, right? So both cosine t and sine t are positive when the terminal side of that angle is in the first quadrant. Okay? Similarly, when the terminal side of the angle crosses the circle in the second quadrant, this point here, any point in the second quadrant, the x coordinate is negative and the y coordinate is positive. So, since the x coordinate is negative, cosine is negative whenever the terminal side of the angle is in the second quadrant. And sine is positive, okay, whenever the terminal side of the angle is in the second quadrant. Okay? Because where it crosses the circle, the x coordinate is going to be negative and the y coordinate is going to be positive. So cosine will be negative, sine will be positive. Okay. All right. So you can carry on that line of reasoning, right, with quadrants 3 and quadrants 4. Okay. All right. Let's go ahead and take your. You got to take your quiz. I want to make sure you have enough time. So we'll stop right there.